So this is chapter 7, section 1. We're going to be solving linear systems by graphing, and we are in unit 8. Okay, so pretty much to kind of summarize this section, we're going to be taking a system of equations, which is two or more equations in two variables, and we're going to be solving this system by graphing. So pretty much we're going to graph this system, these two equations, and we're going to find the point of intersection, and that point will be our solution. So what that means is that x value for the point of intersection, the x value will give us the same y value for both equations. In this case, the x value of 4 gave us the same y value of 2. And if we plug this point into both equations, they would both hold true. So these are our vocabulary words associated with this section. I'll give you time to pause the video so you can copy these down. Okay, so our first vocabulary word is system of linear equations, and this consists of two or more linear equations in the same variable. And I've provided an example here. So we do have two or more equations, and they are in the same variable. What that means is they both use the same variables. So this first equation uses x and y as the variables, and the second equation also uses x and y as the variables. So they're in the same variable, and we have two or more. So this is a system of linear equations. Our next vocabulary word is a solution of a system of linear equations, and this is an ordered pair that satisfies each equation in the system. What this means is I have an x and a y value that I can plug in for each of these, and they will both be true. And we'll talk more about this in the next few slides, and it'll make more sense. But pretty much our solution will be an ordered pair, an x and a y value. So an example, just really quick. If I had 7 for x and 0 for y, this would be 7 plus 2 times 0 would give me 0. So this would hold true for the first equation. 7 plus 0 equals 7. So that would hold true. But if I plugged it into the second equation, if I plugged in 7 for x, I would have 21 minus, plugged in 0 for y, minus 0. That would not equal 5. So this wouldn't be true. So what we're looking for is a point, an ordered pair, that satisfies both equations. And our last vocabulary word is a consistent independent system, is a linear system that has exactly one solution. So pretty much what this is saying is there is only one specific point that will be a solution to our system of equations. So these are the steps involved in solving linear systems by graphing. I'll give you time to pause the video so you can copy these down. Okay, so our first step is to write each equation in slope-intercept form. This is our y equals mx plus b. Our second step is to graph both equations in the same coordinate plane. Our third step is to find our solution, which is pretty much the point where our lines intersect on the graph. And our last step, step 4, is to check our answer. We do this by plugging in our solution, our x and y, back into the original equations and seeing if they still are both true. Alright, so let's solve one of these using our steps. Our first step is to put in slope-intercept form, which is our y equals mx plus b. Alright, so if we take this first equation, we see it's not in the form y equals mx plus b. So to do that, we need to isolate y by itself. So I'm going to start by subtracting 4x from both sides, and that is to cancel out this positive 4x. So subtract 4x, from both sides. That's going to cancel this out. and I'm left with negative 2y equals negative 18 minus 4x. Alright, next step is to divide by negative 2 on both sides. And that will cancel this out here, because instead of multiplying by negative 2, we just divided by negative 2, and that will cancel this out. Since negative 2 divided by negative 2 equals 1, it'll leave us with just 1y. Alright, so we're left with 1y is equal to, I'm going to go ahead and distribute this negative 2 to both terms. So I'm going to have negative 18 divided by negative 2. And then right here, when I distribute this negative 2 over here, I'm going to have, since it's double negative, it's actually going to turn into a positive. And I'm going to have 4 over 2x. So now when I simplify this, I know I want it in the form y equals mx plus b. So I'm going to go ahead and put this term over here in front. So I'm going to have y equals 2 divided by 4. I'm sorry, 4 divided by 2 will give me 2x. And then right here I also have a double negative, so this is going to turn into plus 18 divided by 2 will give me 9. So this is my first equation in slope-intercept form. Alright, now the second one. Now I want to get y by itself, so I'm going to subtract 4x from both sides. Alright, when I do that, this is going to cancel out, and I get left with y equals negative 9 minus 4x. Okay, but I do want it in the form y equals mx plus b, so all I need to do is switch these. So I have y equals negative 4x minus 9. And this is now my second equation that is now in slope-intercept form. Okay, so from here I need to graph both these equations. So to do this, I need to know what my y-intercept is. So in this first equation, my y-intercept is 9. So I'm going to have a point at 9. Put one here at 9. Okay, and my slope is 2, so I'm going to go up 2 over 1. The slope of 2, like I said, is up 2 over 1. If you wanted to go the other way with the slope, you would change the value or the power of each, the numerator and the denominator. So right here, if I switch both of them, I would have negative 2 over negative 1. This is still equal to 2, because this double negative will give me a positive 2. Okay, so now using this slope, I would go down to 1, 2, and then the x value is negative 1, so instead of going positive 1, I'm going to go negative 1. Make a point. So down to negative 1, down to negative 1, and so on. I think I have enough points now. I'm going to go ahead and make my line. So I'm going to use my arrow, and this line is going like so. Okay, I just graphed my first equation. Now let me graph my second one. So my y-intercept on this one is negative 9, and my slope is negative 4. So a slope of negative 4 means I'm going to go down 4 over 1. So if I go down 4 and over 1, I'm going to be off the page. So what I'm going to do is I'm going to flip this slope like I did the other one. So this one's negative, I'm going to change it to positive 4. And this one is positive, so I'm going to change it to negative 1. Alright, so now that means I'm going to go up 4, back 1. And these both are still equal to each other. These are both equal to negative 4. But like I said, I'm going to use this one, so I'm going to go up 4, 1, 2, 3, 4, and then back 1. Up 4, 1, 2, 3, 4, back 1. Up 4, back 1. 4, back 1. Alright, I have enough points now. I'm going to go ahead and make my line. So I have one line, or my line. If I graph it, it's going to look like this. Okay, so now I'm looking for the point of intersection. And my point of intersection, let me get a different color, let me get green, is right here. Alright, and that point is at the x value is negative 1, 2, 3, and my y value is positive 3. So my solution, x value is negative 3, my y value is positive 3. Okay, so now if I wanted to check this in the original equations, I could plug them in. So right here I have 4 times x, which is going to be negative 3, minus 2y, which is 3. And I want to see if these equal negative 18. Alright, so 4 times negative 3 is going to give me negative 12. Minus 2 times 3 is going to give me 6. And if I take negative 12 minus 6, yes, I do get negative 18. So it worked in that equation. So now let me try the second one. I'm going to go ahead and write this one off to the side over here. I have 4 times x, which is negative 3. Plus y, which is 3, and I want to know if this equals 9. Okay, so 4 times negative 3 is going to give me negative 12, plus 3, and yes, that does equal 9. Negative 12 plus 3 equals 9. So yes, that was step 4. I just checked my answer by plugging it back in, and it worked for both equations. Okay, next I want to talk about different possibilities we'll run into when we graph linear systems. We'll have intersecting, parallel, or coinciding lines. Okay, so the kind of lines that we want to get are intersecting lines, because for intersecting lines we do have a solution, and it is one solution. So graphing these two equations, they did intersect at one point, and that point is our solution. So for this example, our solution would be our x value is 4 and our y value is 2. So like I said, we would have one solution. So this would be a consistent independent system. Okay, the next case is if we have lines that end up being parallel. So when we rewrite them in slope-intercept form, we actually see that they have the same slope and different y-intercepts. That means that they are parallel. So graphing these two equations, you'll get a graph that looks like this. So looking for a solution here, we don't have any place where these lines intersect because they never cross since they're parallel. So for this case, we would have no solution. Alright, the third case is if we have coinciding lines. That means that our lines actually end up being on top of each other, or it ends up being the same equation. So over here, I actually wrote out my two equations that actually when I graphed them, they ended up being on top of each other. I didn't write this bottom one as y equals mx plus b slope-intercept form because I wanted you to see that you can't always tell that they will be coinciding lines just by looking at them. You have to write them in slope-intercept form. So I'm going to go ahead and write this bottom one in slope-intercept form. So I'm going to isolate y, and I'm going to start by subtracting 2x from both sides because I want to cancel out this positive 2x. Okay, this gets canceled out. What I do to one side, I have to do to the other side. So over here, I also needed to subtract by 2x. Okay, I'm left with negative 2y equals, and I'm going to go ahead and put this negative 2x in front. And minus 6. Alright, next I need to cancel out this negative 2 here, because right now it's negative 2 times y, so I'm going to divide by negative 2. Okay, so whatever I do on one side I have to do on the other side also. So I'm going to divide over here by negative 2 and over here by negative 2. Okay, so now this is going to cancel out, and I'm going to get left with y equals negative 2 divided by negative 2 is just going to give me 1, so I'm left with 1x, so I can just put x. And then negative 6 divided by negative 2 is going to turn into plus 3, or positive 3. Okay, so now looking at this equation here that I just rewrote in slope-intercept form, it is the same as this equation. So if I do graph these, I have a y-intercept of 3 and a slope of 1, so I'd go up 1 over 1, up 1 over 1. Okay, so these are coinciding lines, so what that means is we'll have many solutions. There's a lot of different solutions we can have. And in the book or in problems, you may see that they'll say any real number. So I kind of want to explain what they mean by that. Okay, what I don't want you to think it means is that for any real number, so our solution is a point, I don't want you to think you can put any numbers in here and that will be your correct answer. So for example, if I put in 1 and negative 2, that's not saying that's what my answer would be. Because even just graphing this point, if I went positive 1, negative 2, yeah, that's not my solution. That's not on the line. What they mean by any real number, so let me write down our equation. Y equals x plus 3. And what we had found out is they actually both ended up being y equals x plus 3. So what they mean by any real number is that any real number we plug in for x in both equations, we will get that same number for y in both equations, which makes sense because they're both the same. So if I did plug in 1 for x in both of these, 1 plus 3, I would get 4 as both my answers. So really what I would have got was 4. And so any real number I plug in for x, so let me just plug in a different number, let's say 8. If I plug in 8 for x in both equations, which is any real number I plug in here, then in both equations I'll get the same number. So 8 plus 3, I would get 11 for both equations. So that's what they mean by any real number. Any real number for x, you'll get the same value for y. Okay, so let me do a few more examples really quick just so we can see kind of some of the ideas we just talked about. Alright, so example 2, I have two equations. First step is to get them in slope-intercept form. This one is already in slope-intercept form, so really all I have to rework is this one. So to isolate y, I would have to divide everything by 2. And I would get, this would cancel out here, I would get y equals x divided by 2, that's kind of taking half of x. So the way we would write that is 1/2 x. You can also think of it as 1x, so it would be 1/2 x. And then negative 2 divided by 2 would give me minus 1. Okay, so now looking at both my equations, y equals 1/2 x minus 1 and y equals 1/2 x plus 3, I do have two equations that have the same slope and different y-intercepts. So I'm not going to go ahead and, I guess I can graph them. Let's say y-intercept of negative 1, the other one has a y-intercept of 3, and this one has a, they both have a slope of up 1 over 2. So that slope would look like this, going in both directions. Alright, my second equation, same slope, so up 1 over 2, up 1 over 2. Okay, so following that same slope, it would look like this, going in both directions. Okay, so yeah, I see that these are parallel, and I could have also just noticed that from the equation they both have the same slope right here, same slope of 1/2. So our solution is actually, we have no solution. So no solution. Okay, in example 3 here, we're still trying to do the same thing. We're trying to solve a system of equations by graphing. So our first step was this: write each equation in slope-intercept form. If we look at this equation here, it is already in slope-intercept form. So only one we need to rewrite is this one down here, equation 2. So if I want to get y by itself and get y equals mx plus b, I need to start moving things to the other side. So to move this positive 3x to the other side, positive 3x, I need to subtract 3x from both sides. So I'm going to subtract 3x on both sides. This is going to cancel out from over here, and I'm going to get left with this 2y equals, here, since I want y equals mx plus b, I'm going to go ahead and put my mx in front. I don't know what the slope actually is yet, but I know this number here, this number x, I want it to be in front of this positive 2. So I'm going to put this plus 2 in the back. Alright, next step here, I still need to get rid of this 2, because right now it's 2 times y. So if I do the opposite and I divide by 2, I'm going to go ahead and do it on both sides. Okay, that's going to cancel out that, and I get left with y equals, I get negative 3 over 2 x, and then 2 divided by 2 is going to give me plus 1. If you didn't switch these here, you would have just switched them right here at the last step. But if you look at these now, we actually have the same equations. We have y equals negative 3 divided by 2x plus 1. So if I did graph these, there would be the same line. So that means that our solution, we have a lot of different solutions, but in the book they'll probably say any real number, or in any questions you may get on any testing, they may say any real numbers, which just means your lines coincide and there's a bunch of different answers. So for example, if I picked, let's say, 0 for x, if I plugged in 0 for x in both these equations, then for y, if I solve this, okay, negative 3 divided by 2 times 0 would give me 0, plus 1, I would get 1 for y in both equations. So any real number for x, I would get the same solution for y in both equations.